Lesson 8.1, Algebra 2B. Today we're going to be studying inverse variation, and at the same time we're going to be reviewing graphs and charts that have direct variation. On your set of notes you'll have two general forms of first direct variation. As you can see from the top of your notes, direct variation basically is any equation that can be written into the form of y equals kx, where k is our constant or slope. And to find that constant, you just simply take y and divide it by x. Inverse variation, which is something new, is down here. That can be represented by y equals k over x. And the constant of that variation is found by taking x times y. Now, one of the skills we want you to acquire in this first lesson is simply to be able to look at a list of points and tell if it's got inverse or direct variation. So let's start by demonstrating with you the four tables that are in front of you, whether or not they have direct variation or inverse variation, and it's possible they could have neither. If I look at number one, I see that the values of x are increasing while the values of y are increasing. If both values of x and y are increasing or decreasing, the only chance it has is direct variation. The next step is to take each y value and divide it by the x value. For example, if you look at the last set of points here, 824, 24 divided by 8 is 3. 18 divided by 6 is 3. 6 divided by 2 is 3. So if you have two values, the y value going up and the x value is going up at a constant rate, which in this case is 3, then you have direct variation. And that constant is going to be y divided by x. And you can pick any one of these two sets, these points here, and divide them out like the last one. 24 divided by 8 will give us 3. The equation of this graph is going to look like this. Y equals 3x. So number one has direct variation. So you would label it as direct variation because the y values divided by the x values will always give you a constant number. Let's take a look at number two then. Number two, as you can see, the x values start at 2/10, then they go to 6/10, then the 1.2. They are increasing, but as you can see, the y values are decreasing. If you look at the y values that are decreasing, so let's take a look at problem number two. We're looking at, again, the x is increasing while the y is decreasing. The only chance we have here is for inverse variation. And that will happen if the x are increasing and the y's are decreasing, along with the fact that if we multiply the x and the y together, or the x and the y, we should get the same exact number. If I take 1.2 times 2, that equals 2.4. If I take 4, or 0.6 times 4, that would be 2.4. As you can see, 12, or 0.2 times 12, that is 2.4. This is a constant, and since we're going up with the x's and down with the y's, we say it has inverse variation. We then represent that by just saying first that it has inverse variation. And the equation that would represent this inverse variation is y equals, let's see, I'm going to erase this so we can, now that we know the constant is always going to be 2.4, we will then simply write out the general form of inverse variation, which is down here, but you're going to replace k with that 2.4. This is the equation of this graph that has inverse variation. Now, I'd like to have you take a moment and do 3 and 4. Tell me if it has inverse variation, direct variation, or neither. And then when you're done, I'll have everything worked out and we'll go over your results. Okay, welcome back. As you can see, I worked out problems 3 and 4. Hopefully you agree with my answers. I look at chart 3 or table 3 with x and y values. Came to the conclusion it had direct variation. First of all, I checked the x. The x's values went up at the same time the y values are going up. And there's a constant of that rate of change, which is found by taking 18 divided by 1.2, 21 divided by 1.4, 24 divided by 1.6 will always give you 15. Put that constant in the form of direct variation in for k. We're going to just basically replace this k up here with that constant, and you get the equation y equals 15x. Another name for constant of direct variation is, of course, the slope. Number 4, you can see that the x values are going down while the y values are going up. And of course, that would not mean that it has direct variation. They both have to be going in the same direction. It could have inverse variation, which it does. The product of x and y is 0.72. That becomes your constant that gets placed with your k. And so you can see how I calculated just 2 points had the same constant. And if you took 1.8 times 0.4, it would be the same answer. So that has inverse variation. And because of the characteristics that we explained. And number 3 has direct variation. Hopefully you match that. Now, the last part of this lesson involves points that are given to us, and they're telling us they model inverse variation. If this happens to you, pull out the inverse variation form, which is y equals kx. And we know in number 1, to find a constant, it's just a matter of taking x times y. So in this case, we'll take 3 times 7, which is 21. So you put in 21 for k, put it over x. There is your equation that models inverse variation that goes through 3, 7. Likewise with number 6, y equals k over x. We can assume that's the form we're going to use. If it has inverse variation, k is equal to 2.5 times 1.5. We can make that assumption because of the fact it says it has inverse variation. This gives you a value of 3.75. 3.75. That's your constant. Simply insert it for k, and that becomes your equation of a graph that has inverse variation and at the same time passes through that point. Hopefully this was helpful. That's basically a summary of 8.1. Now Pearson's going to go into some applications of inverse variation, and hopefully you'll find that interesting. So view that second video after this one, and good luck, and let me know if you have any questions.